Hey guys, so today I'm going to be giving you a brief introduction on reference angles on a unit circle. And since you clicked on this video, I hope you have some knowledge about the sine, cos, and tan values in the first quadrant. I'm mainly talking about 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees, since they're all located in that first quadrant. And with this knowledge, we're going to expand on that and we're going to find sine, cos, and tan of these values in the second, third, and fourth quadrant. So if you know all this, then you are more than capable to find reference angles on unit circles. So without further ado, let's just get started. Alright, so to refresh your minds about the unit circle in the first quadrant, I have this example. And if you want, you can go give it a go if you know the answers. And if you don't, I'm just going to explain it to you right now. So we're just talking about the first quadrant right here. And we want to find the coordinates of each of these blue points. And this is pi over 6 radians, this is pi over 4 radians, pi over 3 radians, and pi over 2 radians. For the duration of this video, I'm going to refer to these angles in radians, not degrees. So essentially, if you want to think about it in degrees, this would essentially be 30 degrees, 45 degrees, 60 degrees, and 90 degrees. But we're just going to go with radians for this one. So let's start with pi over 6. How do we find the coordinates of this point? Because you see, this is pi over 6. This angle right over here is pi over 6. And we're only talking about the unit circle, meaning that it's 1 unit. Hence this one over here. We know that the x-coordinate is cos x, and the y-coordinate, my bad, is sine x. So essentially, cos of pi over 6 or cos of 30 degrees is square root 3 over 2. And the sine of pi over 6 radians, or 30 degrees, is 1 over 2. And these are, you get these numbers when you make a whole triangle, but I'm hoping you guys know how to do that already. This just should be a brief review. For pi over 4, we're trying to find the coordinate of this point right there. Oh, my bad. Yeah, this point right here. And when we do that, the cos of pi over 4 radians, or 45 degrees, is square root 2 over 2. When it's rationalized, you would get 1 over square root 2. If you don't rationalize it, same thing. Sine of pi over 4, or 45 degrees, is square root 2 over 2. And essentially, I'm just going to continue this process. Cos of pi over 3 radians is 1/2. Sine of pi over 3 radians is square root 3 over 2. Cos of pi over 2 radians would be 0. Sine of pi over 2 radians would be 1. And this actually makes perfect sense because if you think about it, pi over 2's point is right over here. And you see it's on the x-axis, so it's on the y-axis, excuse me, which is why our x-coordinate is 0 and we have a y-coordinate of 1 because it's a unit circle. So now we got that out of the way, let's talk about how we can use these values to find reference angles. Maybe say if it's in the fourth quadrant, in the third quadrant, in the second quadrant. Let's start. Alright, so our first example is to find the value of 2 pi over 3, which is located in the second quadrant. And 2 pi over 3 radians is essentially 120 degrees, so it's in the second quadrant. How do we solve this? Well, we know that essentially it's in the second quadrant, right? So cos is going to be negative. That's because the x value is in the second quadrant is negative. So we know that cos is going to be negative. What does that say about sine? Well, we know sine is the y value, and the y value in the second quadrant is positive. So we're going to say that sine x is positive. Alright, and just to clarify this, we're going to find both sine of 2 pi over 3 and cos 2 pi over 3. So I'm just going to write cos and sine of 2 pi over 3. Alright, So here comes the tricky part. Not tricky necessarily, but you need a lot more practice to be an expert at this. So the reference angle will be this. That's what they mean by the reference angle. So what exactly is this? Well, it's essentially just, we know that this is pi, or 180 degrees, and we know that this is 120. So this is essentially pi minus 180 degrees minus 120 degrees, which is 60 degrees, which is also pi over 3 radians. So we know that this is pi over 3 radians. Now what? Well, let's start by solving cos 2 pi over 3. We already know cos has to be negative, so we got the sign out of the way. Oh, the sign, like the negative sign. Okay. We got the sign out of the way. Now, we have to find cos 2 pi over 3. Well, the thing is, cos 2 pi over 3 is the same value as cos pi over 3. That's the thing about reference angles. So we found the reference angle is from here to this negative x-axis. You can't do this line to the positive y-axis. That's not how it works. If you're talking about an angle in the second quadrant, the reference angle has to point towards the negative x-axis, which is why it's pointing this way. Now that we have that, we can recall our values from that first quadrant we had. So now let's see cos of pi over 3. Well, cos of pi over 3 is essentially cos of 60, which is 1/2. But remember, we're in the second quadrant where cos is negative. So we have to put that negative sign. So now we get cos 2 pi over 3 is negative 1/2. This is the exact same thing for sine. Sine of pi over 3, aka sine of 60 degrees, is square root 3 over 2. We know that sine in the second quadrant is positive, so we can just leave it like that. And essentially sine pi over 3, we just saw, is also equal to sine 2 pi over 3. So essentially sine 2 pi over 3 is equal to square root 3 over 2. Alright, so I have another example for you guys. This time the angle is in the third quadrant. And we're trying to find sine of 5 pi over 4 and cos of 5 pi over 4. And for your reference, 5 pi over 4 is equal to 225 degrees, meaning that it's in the third quadrant. Now, the first thing to always do when you see this problem is to find the values of the sine of cos x and sine y, meaning that is cos x negative, is it positive, is sine x negative, or is it positive? Well, we know that the x value in the third quadrant, which is cos x, is negative. So we're just going to say cos x has a negative. We also see that the y value in the third quadrant is negative. So sine x is also negative. Now they both are negative because they're both in the third quadrant. Now that we have the signs, we're going to find the actual value. And the reference angle for an angle in the third quadrant is going to be back to this negative x-axis. It's not going to be to this negative y-axis. Instead, it's going to be to this negative x-axis. That's just how it works. Now, how do we essentially find this? We know that this whole thing is 5 pi over 4. We know that this whole thing is pi. So that's essentially 5 pi over 4 minus pi. Well, 5 pi over 4 minus pi is essentially pi over 4, so we're just going to write pi over 4. And pi over 4 is our reference angle. Notice that last problem and this problem, our reference angles are always less than 90 degrees, or pi over 2 radians. Well, if you get something greater than pi over 2 radians, it won't be the reference angle. Just a hint. So ours is less than pi over 2 radians, so that means this is our reference angle. And now we just have to find cos of pi over 4. Well, cos of pi over 4, we know is square root 2 over 2, or 1 over square root 2. Sine of pi over 4, we can recall that as well. Sine pi over 4 is square root 2 over 2. Now that we have the values, we have to see the sign. Well, we know that cos is negative and sine is also negative. So essentially, cos 5 pi over 4 is negative root 2 over 2. Negative root 2 over 2. And sine 5 pi over 4 is also negative root 2 over 2. Alright, now to our last example, which is located in the fourth quadrant. Once again, we determine the signs of cos and sine in the fourth quadrant. We know that cos, aka the x value in the fourth quadrant, is positive, so we're going to say that cos is positive. And sine, aka the y value in the fourth quadrant, is negative. So we're going to say sine value is negative. Now that we got the signs out of the way, let's move on to find that actual value. Now, the reference angle for an angle in the fourth quadrant is going to be this. So now all we need to do is find this. How are we going to do that? Well, we know that this is 2 pi and this is 5 pi over 3. So 2 pi minus 5 pi over 3 is pi. 2 pi minus 5 pi over 3 is essentially just pi over 3. Just going to say pi over 3. Now let's find the cos and sine values of pi over 3. So we know that cos pi over 3 is equal to 1/2. And that sine pi over 3 is equal to square root 3 over 2, if you rationalize it. Now, here comes the signs. So cos in the fourth quadrant is positive, so we're just going to leave it like that. Sine in the fourth quadrant is negative, so we have to put a negative here. So that would essentially be negative square root 3 over 2 for cos, and positive 1/2.